Now, what I wanted to do real quick is talk about this graph. You may see this graph on the AP exam, you may see this graph on the IB exam. Both of them have that nuclear energy component to it. But I really wanted to quickly talk about it. So this is binding energy per particle. We came up with that. We can come up with that number by using what we did in the last step. We calculated the amount of energy that's the total binding energy. If we divide it by the number of particles, we end up getting the binding energy per particle. Okay, and then under here I have mass numbers. So this is a nice little decay graph. And the reason I'm drawing this graph is to talk about stability. When you look at this graph, you're kind of like, what the heck? What it turns out is that these points where the curves is stable is where there's very little change in the binding energy. This section right here, where I have very little binding energy and mass and very little mass units, this region right here is less stable than this region right here. The flatness of that region is going to give me high stability. So if you look at a relatively flat region in there, you have high stability, where anything else, the higher the curve, the less stable it is. So this region over here has some stability, but it's still relatively unstable, where this region over here has very little stability, which should make sense. If you have particles with very little energy per particle, few particles with very little energy binding them, it doesn't seem to make any sense that those particles would want to bind. Where these regions over here, high number of particles and high amounts of energy per particle. So these regions up here are really relatively stable. They don't like to decay rate. And if you think about it, when we talk about uranium, plutonium, there's a high amount of energy that's bonded there. And there's a high number of particles, which makes these a relatively stable when it comes to radiation. And you're talking about huge half-lives when you talk about plutonium and uranium. So they're relatively stable, but they're still incredibly dangerous to deal with. Where other particles, there's very little, like deuterium, very little binding energy, very little particles. So I mean, deuterium is right over here. Unstable, incredibly unstable. Where you're talking other elements over here that are relatively stable. It doesn't mean that they're not dangerous. It just means that the stability, the decay rate, is a lot less. Okay? Cool? So just if you see this graph on the test, that's what it's trying to tell you. This is meaning relatively unstable, sort of unstable, really stable. Okay, so you're talking iron is going to be in this region. Cool?